Welcome back to my channel, Iron Creek Sniper. What I want to do is just give a brief thing on erosion and what my theory on how gold seems to have, placer gold in special, seems to have accumulated in certain areas. And this is all my theory. I am not a geologist, although I've read and studied for about 10 years, but it doesn't make me a geologist. It's just I read geology and gold is that's all I study, nothing else. All of rock formations, well, that's all part of it. But so in this theory I've got, a lot of people are finding all this gold, and I look how battered up it is. Like it's all just rounded and smashed. Like, you look at this piece here and these, it's all like, how long did it take to break out of quartz and tumble around and end up in the bottom of a stream or a pocket somewhere? And to me, people think, oh yeah, it came out of that mountain there and it's down here. It's like, I think it came from the mountains that were formed and eroded away. I think they call them the ancient Rocky Mountains that have been and gone. And all that material, mountains form, quartz veins are there, the whole mountain erodes away, breaks down, and then all that rock and rubble gets smushed around from various mass erosions and deposited. And then a creek will run through it, and then it'll concentrate it more at the bottom of a creek. So here's the cratons. Those are 3 billion years old ish. That's just a flat piece of land that hasn't been disturbed. It's more inland as opposed to the edge where two continental plates meet and create disruption. Snowball Earth, that's another one. The whole world was covered in ice and snow for quite some time. And so you can imagine there's no trees. And once that all melts, that's going to create mass erosion and swirling stuff around. And then we get the Carnian Pluvial episode, where it rained for over 1 million years. So what did that cause? There has to be mass erosion in that. And of course, the ancient Rocky Mountains, that's the one I was talking about, how they were formed and eroded away, and now new mountains have formed. So where did all that material go? And how much gold was in that? Pangea, we know what that is. That was just the one big tiny chunk of Earth. That was 300 to 400 million years ago. And then everything started shifting around from then, continental plate drift, or whatever you want to call it. Ice ages. Now that's interesting. 2.4 million to 11,500 years ago. And as that receded, it pushed and moved this material that broke away from there around, plus created more. And it was seasonal. It didn't just all melt all of a sudden. It was over the course of quite some span. And then, of course, it sort of melt, maybe ice dams, and they let go, create great big flash floods and churning of earth. And then as they receded, these glaciers that are in valleys that were just sitting there dormant as ice gradually start moving because there's nothing ahead of it anymore, and sliding down and bringing down more dirt and earth. Mass erosion. Oh yeah, geomorphology. Oh my God, that one. If you get into that, I think you've got to study that one because it's totally changed my view on just about everywhere I go. It's amazing the power of the earth. It's like someone took a big chunk of earth, like the earth, and put it in a jar and shook it, and then everything settled as it is. It's like, how did that mountain get there? How did that pile of dirt get there? And each one has a history on how it became what it was. Like moraines and all these different piles of dirt that were pushed from ice ages and earthquakes and volcanic action. And so now you look around, every time I see some earth, I go, wow, how did that form? What is the point behind that? So that's worth looking into. And then it gives you an insight as, all right, the earth is breaking up and it did this. And in all of that, the gold is in there and getting moved around and placed. And So it's water, ice, and gravity. To me, those are the main sources of erosion that create our placer deposits. Gravity, I do like that. It's amazing how powerful that is. But it's a combination of these. And wind, but wind, I don't think that's a big player in the erosion. But that's about it. I think, if I covered that, like I say, I'm not a geologist. All of these things are all related. And I think that if you study that up, it'll give you a better insight. Just look at it. I'm not going to go into detail on all of these different things. It's just stuff that I looked into, and it opened my eyes and go, okay, that's a better understanding. Like my interpretation too, as well, is when you go to a creek and you see all them round rocks, I don't think they were formed from that creek because, for one, they're all different colors. Like they're probably about 8 or 10 different colors, and there's none that look like that in the mountains. Like if you look at the rock formation in the bank, like on some bedrock, it's all one color. And these have been pushed around from all sorts of different sources and suspended in the dirt, and then a creek runs through it, and as the creek runs through it, all that material settles down, down, down as the creek wears its way down, bringing all these round rocks down to the bottom, and they sit at the edge of the creek. I'll have a bit of a story and video on that coming up in the future, but that is interesting because I look at this one creek that I go to, and you look at the source of the rocks there, they're all chippy and they haven't hardly been worn at all. But amongst that, 50% of the rocks is all these round rocks, multicolored and perfectly round. And it's like, that creek couldn't have did that. It's not strong enough. Big boulders and stuff. And then you can travel 500 to 1,000 feet up and find pockets of gravel identical to that. And there's no creek even near there. So that's it. So don't forget to like, subscribe, and notification. So in my next video, I think I'm going to try to incorporate some photos and video of stuff, but I have to go through them all and sort them and then have a better presentation. All right. Thank you very much.